Hey friends, welcome to the YouTube channel All About Electronics. So in this video, we will solve some examples based on the Z parameters. So in the first example, we have been given this resistive circuit and we have been asked to find the Z parameters for the given circuit. So for the given circuit, let's say the voltage V1 and I1 are the voltage and currents on the port 1 side, while the V2 and I2 are the voltage and current on the port 2 side. And here let's say the current in this first mesh is equal to I1, while the current which is flowing in this loop is equal to I3. And let's say the current which is flowing in this last loop is equal to I2. Now here there are two ways by which we can find the Z parameters. The one way is we can consider this port 2 as open circuit or consider this current I2 as 0, and we can find the ratio of this V1 and I1 and V2 and I1, and in this way we can find the Z11 and the Z21. Similarly, by considering this current I1 as 0, we can find the Z12 and the Z22. And in the second method, we can write down the KVL equations for these three mesh and we can find the expression of V1 and V2 in terms of the I1 and I2. So in this way, the coefficients of this I1 and I2 will represent the Z parameters. So in this particular example, we will follow the second method. So first of all, let us write down the KVL equation in this first mesh. So applying the KVL equation, we can write this voltage V1 is equal to I1 times 2 ohm plus the voltage drop across this 1 ohm resistor. Now if you see over here, the net current which is flowing through the 1 ohm resistor is equal to I1 minus I3. And let's say this current is flowing in the downward direction. That means the voltage drop across this 1 ohm resistor is equal to I1 minus I3 times 1 ohm. And if we simplify it, then this voltage V1 is equal to 3I1 minus I3. So let's say this is the first expression. Similarly, now let us write down the KVL equation in this second mesh. That means we can say that 2 ohm times I3 plus the voltage drop across this 1 ohm resistor, that is 1 ohm times I3 plus I2 plus the voltage drop across this 1 ohm resistor. So in this case, the net current which is flowing through the 1 ohm resistor is equal to I3 minus I1. So we can say that it is equal to 1 ohm times I3 minus I1, that is equal to 0. So if we further simplify it, then we can write 2I3 plus I3 plus I2 plus I3 minus I1, that is equal to 0. Or we can say that 4I3 is equal to I1 minus I2. That means I3 is equal to 1 by 4 times I1 minus I2. And let's say this is the second expression. Similarly, now let us write down the KVL equation in the last mesh. So applying the KVL equation, we can write voltage V2 is equal to 3 ohm times I2 plus the voltage drop across this 1 ohm resistor, that is equal to 1 ohm times I2 plus I3. That means V2 is equal to 4I2 plus I3. And let's say this is the third expression. So now let us put the value of current I3 in the third expression. That means we can say that voltage V2 is equal to 4I2 plus 1 by 4 times I1 minus I3, that is equal to 1 by 4 times I1 plus 15 by 4 times I2. Similarly, now let us put the value of I3 in this first expression. That means voltage V1 is equal to 3I1 minus 1 by 4 times I1 minus I2, that is equal to 3I1 minus 1 by 4 times I1 plus 1 by 4 times I2. That means V1 is equal to 11 by 4 times I1 plus 1 by 4 times I2. So in this way, we got the expression of V1 as 11 by 4 times I1 plus 1 by 4 times I2. And similarly, the voltage V2 is equal to 1 by 4 times I1 plus 15 by 4 times I2. Now if we compare these two expressions with the standard expression of the Z parameter, then we can say that here Z11 is equal to 11 by 4 while Z12 and the Z21 are 1 by 4, and similarly the Z22 is equal to 15 by 4. So if we write these Z parameters in the matrix form, then we can write this Z matrix as 11 by 4, 1 by 4 and 1 by 4 and 15 by 4. So these are the Z parameters for the given circuit. Similarly, now let us see the second example. So in this example, we have been given this lattice network and we have been asked to find the open circuit impedance parameter for the given circuit. Now here we have been given that the value of ZA is equal to 4 ohm while the value of ZB is equal to 2 ohm. So basically we have been asked to find the Z parameters for the given lattice network. So let's say here the voltage and the current at the port 1 are V1 and I1 while the voltage and current at the port 2 are V2 and I2. So here to find the Z parameters, first of all what we will do, we will consider this current I2 as 0, and considering this we will find the Z11 and the Z21, and similarly by considering I1 as 0 we can find the Z parameters Z12 and the Z22. So first of all let us assume that this current I2 is equal to 0. Now in this condition if you observe, this current I1 gets divided into the two branches. So the one portion of the current will flow through this impedance ZA and the ZB, while the another fraction of the current will flow through this ZB and the ZA. And if you observe over here, in both branches the resistance are equal. That means this current I1 will get equally divided in the two branches, or in other words we can say that this current I is equal to I1 by 2. So now let us apply the KVL equation in one of the mesh and let us find out the Z11. So applying the KVL equation in this mesh, we can write voltage V1 is equal to ZA times I plus ZB times I, and here this current I is equal to I1 by 2. So we can write voltage V1 is equal to I1 by 2 times ZA plus ZB, or we can say that the ratio of V1 by I1 when current I2 is equal to 0, or Z11 is equal to ZA plus ZB divided by 2. Similarly, to find this Z21, let us apply the KVL equation in this loop. Now here if you observe, the current I is flowing in this direction, while in this impedance ZB, the current I is flowing in this direction. So applying the KVL equation, we can write voltage V2 is equal to ZA times I minus ZB times I, and here I is equal to I1 by 2. So we can say that V2 is equal to I1 divided by 2 times ZA minus ZB, or we can say that the ratio of V2 and I1 when current I2 is equal to 0, or Z21 is equal to ZA minus ZB divided by 2. So in this way we got the value of Z11 as ZA plus ZB by 2 and the value of Z21 as ZA minus ZB divided by 2. Similarly, by considering this current I1 as 0, we can find the value of Z12 and the Z22. But if you observe the circuit, then this circuit is symmetrical as well as the reciprocal. That means here this Z11 is equal to Z22 and Z21 is equal to Z12. So from this we can say that this Z11 and the Z22 is equal to ZA plus ZB divided by 2, while this Z21 and Z12 are ZA minus ZB divided by 2. And here the value of ZA is 4 ohm while the value of ZB is 2 ohm. That means Z11 is equal to Z22 is equal to 4 plus 2 divided by 2, while the ZA minus ZB divided by 2 is equal to 4 minus 2 divided by 2. That means Z11 and the Z22 is equal to 3 ohm while the Z21 and the Z12 is equal to 1 ohm. And if we write the Z parameters in the matrix form, then it will be equal to Z11, Z12, Z21 and the Z22. That is equal to 3, 1 and 1, 3. So these are the Z parameters for the given circuit. Similarly, now let us see the third example. So in this given two-port network, there is a dependent source. So now let us see how we can find the Z parameters when the circuit contains the dependent source. So here, let's say the voltage at the port 1 is equal to V1 while the voltage at the port 2 is equal to V2. So here the current in this loop is equal to I1 while let's say the current in this loop is equal to I2. So here we will find the expression of V1 and V2 in terms of the I1 and I2. And comparing those expressions with the Z parameter equations, we can find the value of the Z parameters. So for that, first of all, let us write down the KVL equation in this first loop. So applying the KVL, we can write voltage V1 is equal to 2I1 plus 1 ohm times I1 plus 1 ohm times I1 plus I2. That means V1 is equal to 4I1 plus I2. So if we compare this expression with the first expression, then we can say that here Z11 is equal to 4 ohm while the Z12 is equal to 1 ohm. Similarly, now let us write down the KVL equation in the second loop. So from the second loop, we can say that the voltage V2 is equal to 1 ohm times I2, that is the voltage drop across this 1 ohm resistor, plus 1 ohm times I1 plus I2. That means voltage V2 is equal to I1 plus 2I2. And if we compare this expression with the standard Z parameter equation, that is V2 is equal to Z21 times I1 plus Z22 times I2, then we can say that here Z21 is equal to 1 ohm while the Z22 is equal to 2 ohm. So in this way, here Z11 is equal to 4 ohm while Z12 and the Z21 are 1 ohm. And similarly, the Z22 is equal to 2 ohm. So these are the Z parameters for the given circuit. Similarly, now let us see one more example where the two-port network contains the dependent source. So in this question, we have been asked to find the Z parameters for the given circuit. So in this circuit, we will find out the expression of V1 and V2 in terms of the I1 and I2. And comparing those expressions with the standard Z parameter expressions, we will find the values of the Z parameter. So here if you observe, the voltage at this node is equal to V1. Similarly, the voltage over here is equal to V2. And let's say the voltage at this node is equal to V3. So here we will write down the KCL equations at the three nodes. And using those equations, we will find the Z parameters. So first of all, now let us apply the KCL equation at the first node. So applying the KCL equation, we can write current I1 is equal to V1 divided by 1 ohm, that is this current, plus V1 minus V3 divided by 1 by 2 ohm, that is this current. That means current I1 is equal to V1 plus 2 times V1 minus V3, that is equal to 3V1 minus 2V3. That means current I1 is equal to 3V1 minus 2V3. And let's say this is the first expression. Similarly, now let us apply the KCL equation at this node. So applying the KCL equation, we can write 2V1 plus V3 minus V2 divided by 1 ohm, that is this current, plus V3 minus V1 divided by 1 by 2 ohm, that is this current, is equal to 0. Or we can say that 2V1 plus V3 minus V2 plus 2V3 minus 2V1 is equal to 0. Or we can say that 3V3 is equal to V2. That means V3 is equal to V2 divided by 3. And let's say this is the second expression. Similarly, now let us write down the KCL equation over here. So applying the KCL equation, we can write current I2 is equal to V2 divided by 1 by 2 ohm, that is this current, plus V2 minus V3 divided by 1 ohm. That means current I2 is equal to 2V2 plus V2 minus V3, that is equal to 3V2 minus V3. And let's say this is the third expression. So now let us put the value of V3 in the third expression. That means V3 is equal to V2 divided by 3. So we can say that current I2 is equal to 3V2 minus V2 divided by 3, that is equal to 8V2 divided by 3. Or we can say that voltage V2 is equal to 3 by 8 times I2. Or if we write the same expression in a different way, then we can say that voltage V2 is equal to 0 times I1 plus 3 by 8 times I2. And if we compare this expression with the standard Z parameter expression, then we can say that here the Z21 is equal to 0 while the Z22 is equal to 3 by 8. Similarly, now let us also put the value of V3 in the first expression. That means current I1 is equal to 3V1 minus 2 times V2 divided by 3. And here we know that the voltage V2 is equal to 3 by 8 times I2. That means we can say that current I1 is equal to 3V1 minus 2 by 3 times 3 by 8 times I2. That means current I1 is equal to 3V1 minus 1 by 4 times I2. That means 4I1 is equal to 12V1 minus I2. Or we can say that V1 is equal to 1 by 3 times I1 plus 1 by 4 times I2. And if we compare this expression with the standard Z parameter expression, then we can say that here Z11 is equal to 1 by 3 while Z12 is equal to 1 by 12. So here if we write the all Z parameters, then Z11 is equal to 1 by 3 while Z12 is equal to 1 by 12. Similarly, the Z21 is equal to 0 while the Z22 is equal to 3 by 8. So these are the Z parameters for the given circuit. So that's it for this video, and I hope in this video you understood how we can find the Z parameters for the different circuits. So if you have any question or suggestion, do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.